as Elon Musk, the founder and chief executive of SpaceX, says repeatedly, he created a rocket company because he wanted to colonize Mars. His fervent argument is that humanity must spread to a second planet as insurance for long-term survival. And for that purpose, he has created the magnificent Super Heavy. Don't forget to watch today's video to the very end to understand why the SpaceX insane new Super Heavy has no competition. Which future do you want? He asked near the start of the presentation on Saturday night at a launch site near the southern tip of Texas, during which he said the options were being confined to Earth or become a spacefaring species. Mr. Musk said he hoped the audience agreed that humans should prepare for life elsewhere in the solar system as he delivered a progress report on STARSHIP, a giant rocket that is the centerpiece of his ambitions. Standing before the prototype and an older rocket built early in the company's history, he pledged that STARSHIP would first take off to an altitude of 65,000 feet and then land in about 1 to 2 months. "This is going to sound totally nuts," he said later, "but I think we want to try to reach orbit in less than 6 months," adding that this timeline relied on continued improvements in manufacturing the rockets. What is STARSHIP? STARSHIP is the latest name for the upper stage of what Mr. Musk had been calling BFR. The B stood for big, the R stood for rocket. And Mr. Musk never publicly stated the meaning of F. SpaceX currently flies 2 rockets, the Falcon 9 and the Falcon Heavy, which is essentially a Falcon 9 with 2 additional Falcon 9 boosters attached to the side. The present-day Falcons are too small for sending people to Mars. Mr. Musk and SpaceX have long envisioned a much larger rocket. For a while, Mr. Musk referred to it as the Mars Colonial Transporter. But when he finally revealed a design at the International Astronautical Congress in Guadalajara, Mexico, in 2016, he called it the Interplanetary Transport System. This spaceship was gargantuan, with a diameter of nearly 40 feet and the capacity to take 100 people to Mars. A year later in Australia, Mr. Musk said the rocket had been scaled down by 1/4 to a diameter of 30 feet. This was the BFR. The second stage was sleek-looking spacecraft that would return to Earth in one piece and land vertically. Last November, SpaceX announced the STARSHIP name. The first stage of BFR is now known as the Super Heavy booster. In recent days, Mr. Musk has been posting updates as the prototypes come together. On Saturday before Mr. Musk's presentation, SpaceX highlighted STARSHIP's size by displaying it alongside the company's original Falcon 1 rocket, which first launched to orbit in 2008. Can this really be done? STARSHIP with the Super Heavy booster is essentially a rocket as powerful as a Saturn V, which took NASA's Apollo astronauts to the moon 50 years ago. But it's fully reusable. For Apollo, everything but the small capsule on top, where the astronauts sat, was discarded along the way, and even the capsule could only be used once. Experts say STARSHIP is within the realm of the possible, without requiring impossible physics or unlikely technological leaps. Indeed, STARSHIP employs ideas that were studied decades ago but never built. The biggest innovation is perhaps that SpaceX and Mr. Musk have applied the accelerated research and development approach of Silicon Valley, building fast and fixing failures fast. 2 competing teams at SpaceX are each building prototypes of STARSHIP. One is in Florida, near Cape Canaveral. The other is at Boca Chica in Texas. Why is STARSHIP shiny in silver? While most rockets these days have more utilitarian appearances, SpaceX's prototype resembles something from an old sci-fi movie of the 1950s. In part, this is because in its rush to get the prototypes to the launch pad, SpaceX has not bothered with such aesthetic niceties as paint. But there also are good engineering reasons for the choice of material. Mr. Musk originally had planned to use high-tech carbon fiber, but switched to stainless steel. Steel is heavier than carbon fiber and aluminum, another common material used for rockets, but it is also cheaper, about 2% of the cost of carbon fiber, Mr. Musk said, and has a higher melting temperature that can more easily withstand the heat of re-entry into Earth's atmosphere. Didn't SpaceX already fly a big rocket? In August, SpaceX tested a simple prototype that it called Starhopper with a single engine, which Mr. Musk earlier compared to a flying water tower. It lifted to an altitude of 500 feet, flew sideways, and then set down at a different spot. Why? Self-sustaining civilization on Mars. SpaceX started with a well-defined goal and a blank sheet of paper, rather than complicated contractual obligations and an instinct to reuse what they already had. Everything that SpaceX does is about creating a self-sustaining civilization on Mars. That goal won't seem important to everyone, but to a lot of people, It's incredibly exciting. I imagine that the folks who work for SpaceX are pretty darned engaged. Having a clear mission is a fantastic way to focus the mind. It encourages folks to direct all their energies with the goal in mind, which lends itself perfectly to lean development ideas. How? Solving the transportation problem. From SpaceX's goal, it's possible to extrapolate the biggest constraint. Mars is pretty hard to get to. If any scientific, commercial, or government entity is considering doing anything on Mars, it's significantly easier if you know that when you are ready to go, it'll be possible to buy a ticket on a Starship for a predictable and affordable price. Imagine if the Apollo program had the option of buying a ticket on a Starship. Sure, they would still have needed to figure out how their astronauts were going to survive on the lunar surface, but the Saturn V would not have been necessary, saving the US taxpayer a fortune. What? Cheap, powerful rockets. A commercially viable Mars or Moon rocket that's capable of supporting a base city would need to be significantly cheaper than the current models. It would also need to be capable of transporting significantly greater payloads over much bigger distances. There is one key feature of Starship that makes this possible: reusability. As Elon Musk often says, imagine if you built a new 747 for every flight. How much do you think the average ticket from Heathrow to JFK would set you back? Reusability is the holy grail of affordable spaceflight. Before SpaceX, the space shuttle had also aimed for reusability. Unfortunately, it failed miserably. The big orange fuel tank wasn't reusable. The white side boosters parachuted back to Earth and were fished out of the ocean. However, preparing them for reuse after they'd been swimming in salt water was terribly inefficient. For the SLS, they'd taken those side boosters and upgraded them to be single-use rockets, saving the expense of reusing them. As for the space plane, the astronomical cost of renovating the shuttle between launches, coupled with the maddeningly inefficient design, rendered the whole process more expensive than most single-use rockets. In contrast, Starship is designed to be fully and efficiently reusable, including the super-heavy first-stage rocket. All the rockets can land themselves on pads or drone ships. SpaceX is even aiming to land Starships directly on the launch pad, ready to relaunch just 1 hour later. For comparison, on average it takes 1.5 to 2 hours to turn around a 747, and it took over a year to turn around a space shuttle. Putting it all together, combine those 3 key features, and you can begin to appreciate how SpaceX is able to deliver a rocket that is such a giant leap compared to the Saturn V, Space Shuttle, or SLS. As a demonstration of the sort of leap SpaceX has taken, NASA recently selected 3 potential lunar landers for its upcoming moon program. 2 of them, Blue Origin and Dynetics, have proposed small, light, bungalow-sized, spidery-looking vehicles that would probably travel on an SLS, Starship, or Blue Origin's New Glenn rocket. These new landers look a bit like the Apollo landers. A brief side note on Blue Origin, another SpaceX competitor. Headed by Jeff Bezos, there was a time when folks dismissed SpaceX Blue Origin was better funded. Musk was successful, but Bezos was in a different league. Blue Origin actually managed to land its New Shepard rocket in November 2015, a month before SpaceX landed a Falcon 9. Although the Falcon 9 was a much bigger rocket, so landing it was a significantly more impressive feat. Since then, Blue Origin simply hasn't kept up. Like the SLS, the New Glenn is less powerful than a Starship, further behind in development, and improving less quickly. For us, comparing SpaceX to Blue Origin is like comparing the Wright brothers to Samuel Pierpont Langley. Anyway, moon landers. The third lander option was a full-blown, skyscraper-sized Starship. Imagine how many more people and how much more equipment something that size could ferry to the moon. If your intention is to set up a moon base, it's easy to imagine how much more effective Starship could be. Of course, if NASA does select Starship, that would make the SLS redundant for any such moon mission. And the SLS was specifically designed for these sorts of missions. With that, we come to the end of today's video. Don't forget to join in the next time for more of such interesting content.